First of all, I've mounted the PDB that comes shipped with it down here. I've put a 12 volt BEC on there, and then that's going to deliver power to the video transmitter and the camera after going through an LC filter. More on that later. The silicon standoffs here from Lumenier are going to support the flight controller, and being silicon, they help absorb some of the vibrations and stop them getting through to the flight controller. The flight controller here, the Motolab F3 Tornado, I've mounted the 5 volt BEC on the back of that. It solders through to the front there, and that will deliver power to the flight controller and receiver. The motors are going on. Change of plans. The QAV180 is now getting the RCX 2205 2633 kV motors. This is really going to improve the performance of this little quad. Got something else planned for the Mitsuko now, which I'll come to later as well. Little B ESCs are going on. I cut the heat shrink off them so I can get to the wires properly, and then put new heat shrink on, black in this case. The last one here is about to get fitted up, so I use a bit of tape on the bench to hold the ESC steady. Using a very hot soldering iron, I very quickly, so that I don't deliver too much heat to the ESC, I remove the 3 motor wires that are connected to the ESC so that I can solder the new motor wires directly to it. I used to cross wires to get the reverse motor direction, but nowadays I just solder them all up straight and then use the BL Heli suite to adjust motor direction later. Now the motors are all mounted on the frame, and the ESC power leads are connected to the PDB along with the battery pigtail. Now normally I would use angle header pins on the flight controller to connect the servo leads from the ESCs, but for this build I plan to cut these servo leads and solder the signal and ground wire directly to the flight controller. Because it's a Motolab Tornado board, it doesn't support the BL Heli one wire pass-through, so I'm going to use my Arduino Nano stick here to program the ESCs and to set the motor direction using BL Heli suite on the laptop before I connect these to the flight controller. It's not impossible to do it afterwards, but it's a lot easier if I do it now before they're soldered on the board. The QAV180 build is now complete. I've flashed the latest version of Betaflight for the Motolab board onto the flight controller, and I've used CleanFlight to configure the flight controller. I've got it all bound to this Tyrannus transmitter. This one is actually currently set up mode 1, which I need to change to mode 2 before I go much further. So the build went well. What I would like to point out is that this comes with a few extra things that some frames don't, that could be considered of value. So an XT60 piggy tail with this little grommet, this battery foam here, a nice battery strap, and a good quality PDB all come with this frame included in the price. Perhaps $10 worth, let's say. Here's some leftover bits. I've got a camera plate, board cam plate. So because I've used the 1177 in the plastic case, I haven't needed that, but it's there if somebody wanted to use a board cam. Some leftover hardware, including these little aluminium standoffs and rubber feet that act as landing gear. I've decided not to bother with fitting landing gear, and I've got all the plastic standoffs left over because I used the silicon standoffs for the flight controller. So the moment of truth now. Time to see what the baby weighs. 289 grams without a battery. This is a 4S1000 battery, typical about 122 grams. Yep, that comes in at 410 grams with a 4S battery. So now it's time to go and put it in the air and do some tuning. Have a look at this. It is possible to build a 4-inch quad and still have room for a GoPro session with a 4S 1000 mAh battery.